Alright guys, I'm going to do a quick video on what isotopes are. So first of all, I want you to know that isotopes are like a little bit of a different version of the same element. They're all the same element, just slight differences, and we'll talk more about what those differences are. Okay, there's two ways of writing an isotope. You can either write it as in hyphen notation, or you can write it as a nuclear symbol. So in hyphen notation, you can write the name of the element followed by a hyphen and then the mass. Okay. You can also do the symbol of the element, a hyphen followed by the mass. With a nuclear symbol, you give a little bit more information. You write the symbol of the element. On the top left, you would write the mass. And then on the bottom left, you would write the atomic number of that symbol. But let's go ahead and look at what makes an isotope an isotope. Okay, so in the periodic table, you're really not going to see isotopes. You see one version of it. But if you notice, these numbers are in decimal form. That's because they got an average of all the possible versions of those elements, and then they averaged it together, their masses, and then that they call this the average atomic mass. But again, like I said, you don't really see all the versions of it. So let's take a look at the element nitrogen. Okay, so here's nitrogen. And with nitrogen, guys, we see that there's one element. But in reality, there's different versions of it. Let me go ahead and show you. Okay, so nitrogen has an isotope with a mass of 15, and it has an isotope with a mass of 20. And if you look at nitrogen, you see the mass is 14.007. When we're talking about isotopes at this point, you're almost disregarding the fact that that's there. You're focusing on the mass that's given to you for that isotope. So as we go ahead and write a nuclear symbol for the isotope, we put the mass that's given to us, not the one on the periodic table. So then that would be 15, and then the atomic number on the bottom. So that's something that isotopes will all share. They'll all share the same atomic number because they are really the same element. It's just a difference in their mass, and therefore a difference in the number of neutrons, because remember that neutrons, we use a mass to calculate them. Okay, so if we look at the protons, notice that the protons for isotopes are the same. That doesn't change because the atomic number is the same. But when we come to neutrons, and I went ahead and highlighted that, notice that the neutrons are different. And that's because the masses of the isotopes are different. So in this case, if I do, remember, 8 man, so man, mass minus atomic number, it's going to be 15 minus 7. That's going to give me 8 neutrons. If I do the neutrons for this isotope, the mass for this isotope is 20. So it's 20 minus 7, and that gives me 13. So as you notice, the neutrons are different. The masses will be different. The electrons, again, because of the ape part, remember, atomic number, protons, and electrons are the same. That means that 7 will also be how many electrons I have for that isotope. Notice in my other example for sulfur, it's the same situation. Okay, here are 2 isotopes of sulfur. Again, if I look at sulfur on the periodic table, notice that it says that the mass is 32. But we're not going to go ahead and go with that mass. We're going to go with the mass of the isotope. So in this case, again, we are disregarding the 32.068. We're going with the mass of this isotope as 31 and the mass that's given to us as 35. So as we write their nuclear symbols, remember, you write the mass on top, which is 31, the atomic number on the bottom, and then the symbol to the right. Same thing with this one. But notice that the masses are different because they are different isotopes of the same element. Okay, just like I said in the previous example, protons are the same. Protons are the same. You'll notice that the neutrons are different. Why? Because I subtracted the mass by the atomic number. 31 minus 16 is 15. Here I subtracted the isotopic mass of sulfur. 35 minus 16, that gave me 19. So even though they're the same element, they are isotopes of each other, which means that their neutrons and their masses are different. For electrons, as mentioned before, they're the same as the protons. Okay, so this is how you figure out isotopes and their number of neutrons. And remember that protons and electrons stay the same. And keep in mind that the mass that you see for that isotope may not be the same mass that you see on the periodic table.